Getting caught in the wrong shoes can interrupt your plans for the day, like when that 10% chance of rain ends up looking more like 100%. When the transition to fall and winter feels more like experiencing every season on the same day, there's the Allbirds Mizzle collection. These shoes were made for misty morning walks, surprise snow days, and anything a trip to the dog park might bring. The whole collection brings together water-repellent technology and classic style, so you can stay warm, dry, and comfy during your everyday adventures. Cross off errands with the splash protection on the Wool Runner Mizzle. Dash through cold and wet weather with all-condition traction and reflective details on the Wool Dasher Mizzle. Or upgrade to next-level protection with the Mudguard on the Wool Runner-Up Mizzle Plus. Go to allbirds.com and use code FRESHSOCKS for a free pair of socks with your purchase. ALLBIRDS.com, code FRESHSOCKS.
Introducing Carvana Value Tracker, where you can track your car's value over time and learn what's driving it. It might make you excited.
Whoa, didn't know my car was valued this high.
It might make you nervous.
Uh-oh, market's flooded. My car's value just dipped 2.3%.
It might make you optimistic.
Our low mileage is paying off. Our value's up.
And it might make you realistic.
Car prices haven't gone up in a couple weeks. Maybe it's time to sell.
But it will definitely make you an expert on your car's value. Carvana Value Tracker. Visit Carvana.com to start tracking your car's value today.
This is SpaceTime Series 25, Episode 137, for broadcast on the 19th of December 2022. Coming up on SpaceTime, the mysterious meteor that changes everything, NASA's Artemis 1 mission declared a massive success, and nuclear fusion achieved in the lab. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers believe that a meteor which streaked across the darkened skies of central Alberta didn't originate from the inner solar system as most meteors do, but from the far reaches of the distant Oort cloud. The findings, reported in the journal Nature Astronomy, challenge some key aspects of science's understanding of how our solar system formed and evolved. It's thought that substances like iron and silicon condense out of the gaseous protoplanetary disk close to the Sun, where temperatures are warm, while more volatile materials like hydrogen, helium, methane and ammonia condense out in colder, more distant regions beyond the so-called snow line, where water naturally forms as a solid. That's why the terrestrial planets, Mercury, Venus, Earth and Mars, are in the inner solar system, while the gas giants Jupiter and Saturn and the ice giants Uranus and Neptune make up the outer solar system. And like the planets, rocky asteroids tend to mostly orbit in the inner solar system, while icy comets originate further out beyond Jupiter, even as far away as the Kuiper Belt beyond Neptune, and even in the more distant so-called Oort cloud. The Oort cloud is a hypothetical sphere of frozen worlds, comets and icy debris dragged along at the very outer edge of the solar system and possibly stretching up to a light year away in interstellar space. Because they're so far away, the collection of icy objects making up the Oort cloud are influenced not just by the Sun's gravity, but also by the gravity of passing stars. And that can nudge them out of their orbits, sending them hurtling towards the inner solar system, where we are. While astronomers are yet to directly observe any objects coming from the Oort cloud, everything detected so far coming from this direction is made of ice. That was until now. That meteor spotted streaking across the skies of central Alberta was coming from the direction of the Oort cloud. But it was rocky, not icy. And that challenges some long-held beliefs not just about how the solar system was formed, but what the Oort cloud itself is composed of. Now, theoretically, the very basis for understanding our solar system's beginnings is built upon the foundation that only icy objects exist out at these outer reaches. At these distances, there's simply nothing made of rock. But one of the study's authors, Dennis Vida from the University of Western Ontario, says this new discovery supports an entirely different model for the formation of our solar system. One which backs the idea that significant amounts of rocky material coexist with icy objects within the Oort cloud. He says the findings simply can't be explained by the current favoured solar system formation models. It's a complete game changer. All previous rocky fireballs spotted in Earth's atmosphere have arrived from much closer to the Earth, making this body, which clearly travelled from the direction of the Oort cloud, completely unexpected. The observations were made using state-of-the-art global fireball observatory cameras developed by Curtin University in Western Australia and run by the University of Alberta. They observed the grapefruit-sized 2-kilogram rocky meteoroid as it streaked across the sky. During its flight, the Alberta fireball descended much deeper into the atmosphere than icy objects on similar orbits, and it broke apart exactly like a fireball dropping tiny stony meteorites, the necessary evidence that it was in fact made of rock. Vida says that conversely, comets are basically fluffy snowballs mixed with dust that slowly vaporize as they approach the sun. The dust and gases within them form their distinctive tails, which can stretch for millions of kilometres. Dr. Ellie Sansom from Curtin University says astronomers want to explain how this rocky meteoroid ended up so far away from Earth. It'll help scientists better understand the evolution of the solar system and maybe even how the conditions which sparked the development of life might have come into being. She says it'll also help astronomers paint a picture as accurately as possible of the earliest moments of the solar system, a time that was so critical for everything that was to happen afterwards.
We lead what's called the Global Fireball Observatory. We have cameras all the way across Australia and now the world taking pictures of these really bright shooting stars that we call fireballs. And the idea is that from all these different locations around the world, you can figure out where these objects are coming through the atmosphere. It's a little bit like how you use your two eyes to gauge distance. We can use our different cameras to figure out where these objects are coming through the atmosphere. The main aim for us is to figure out where these objects might actually fall as meteorites, also backtrack and find their orbits and where they come from in our solar system. So there's about 70,000 meteorites in collections around the world that we basically use to figure out how our solar system formed and evolved and try to inform models of that and maybe how water came to Earth and maybe how life came to Earth. But there's less than 50 meteorites in those collections that we know where they come from. And that's those rocks that we recovered, we get that understanding of where they come from based on these fireball camera networks that are around the world. So trying to figure out their orbits, basically we backtrack and figure out where they're coming from around the sun. And most of the rocks that we see from these fireball camera networks are coming from an area called the main asteroid belt, or like you're saying, there's Apollo orbits, there's Aten orbits, there's a bunch of different fancy names for where these things are coming from, but most of them are within the orbit of Jupiter.
And it's usually also in the plane of the solar system, where most of the
it was a spinning ball of gas that slowly collapsed down to a disk, and that's where most of the material in our solar system is in that disk. And like you said, that's where most of these objects that come flying towards Earth come from. Now, this one was really interesting. So we've managed to back calculate the orbit of this object, and it came in so fast, it came in at around 62 kilometers per second. That's like going across the country in a couple of minutes.
That's more like a comet than an asteroid.
Yeah.
Isn't it?
Yes, and that's actually really what we're really surprised about is the material that's coming from that far away that comes in at those speeds. We usually associate with cometary material. Now, cometary material is a combination of mostly icy and dusty material, and when they come close to the sun, they start shedding that or melting or sublimating and leaving that trail of gas and dust behind them. But when we try to model how our solar system formed and evolved, we usually say, well, all the icy stuff is all the way out there and all the rocky stuff is here in the middle. But this object that we saw come from all the way out there was not something fluffy and icy when it came through. It was really quite strong. And so we were able to, although it didn't drop a meteorite that we can go and recover, its trajectory through our atmosphere, we were able to figure out that it was something that was really quite strong. It punched so deep into the atmosphere that it can't have been anything other than rocky material. So this is the first time we have seen something that large come from that far away and not be icy.
It's an interesting time to talk about this because we've got the Geminids meteor showers happening now, and the Geminids are caused by a very interesting meteor, a very interesting asteroid, which a lot of people refer to as a rock comet.
Yeah, so something that with the Desert Fireball Network and the Global Fireball Observatory, we keep saying, we're trying to see all of these objects come up through our atmosphere to figure out if there are any things called asteroid streams. So meteor streams or meteor showers come from known parent bodies that are typically icy, rocky material, and they leave that trail of gas or dust and ice behind. And as the Earth comes through that trail, we get that shower all at once. 99% of these are definitely icy, rocky bodies that we're intersecting the dust particles from. But the Geminid meteor shower is one that, is very unique. Parent body that it comes from that we have seen with telescopes, it's not what we call outgassing. It's not spewing out icy, dusty particles in the same way. So some people think that this is an asteroid stream. It is an asteroid that is just shedding off rocky material as it goes around the sun rather than ice and dust.
This is the asteroid Phaeton we're talking about here.
Yes, comet.
Most meteor showers come from comets, but there are two annual ones which we know of, Phaeton being one of them, Geminids in other words, which appear to come from asteroids, but they're asteroids on really unique orbits, very comet-like orbits.
We still call them comets, but there's still a very strong debate about whether we can actually call them comets. And some people call Phaethon a dead comet. They think maybe it's the remnant of an old comet and we've just gone all the way down to the core. It's lost all of its icy material and it's no longer spewing material out, and it's a dead comet. So the actual, although the material we're coming through could still be from remnant times when it was icy and just dust, what we're seeing as the parent body with the telescope is just a dead comet now. But it's really, like you said, it's on a really interesting orbit. So was it once a comet? Or was it actually something from the main inner asteroid belt where all this rocky material usually sticks around and got flung out? And that's what this paper is basically saying, is that there's a few different models of how our solar system formed. Some of them say that everything just formed in place, and what we see today very similar to those early days, and there's not much migration that has happened between all the bodies. But there's other ones that are saying that the big planets like Jupiter and Saturn have actually caused a lot of chaos in our history, and they've caused the material to move around from the inner solar system to the outer solar system and vice versa. And
this is the grand TAC model here of post-migration.
Yes, it's using these great planets that have kind of got into what we call a resonance, and then they basically get a bit unhappy with sitting that close together in orbital space and make all of the material fly around. And so that's what we're now looking into, is that this is actually this object that we've seen that is rocky material on a cometary-like orbit. And we've actually worked out there's about 1 to even 20% of contamination of rocky material in that far away Oort cloud, which is basically saying there has to have been this large, chaotic early solar system. And Jupiter and Saturn might not actually have formed in their positions that they are today. They might have formed a little bit closer in or a little bit further away. And that giant planet, what we call giant planet migration, is when they have interacted with each other and thrown material out, but also changed their own orbits as well.
It really is the most beautiful, elegant puzzle, isn't it?
It's a very fun one, and hopefully the more we observe, the more we can answer the questions. And there's just so many questions, and sometimes you just make more questions.
As scientists, we tend to put things in boxes because that's our nature. We like to classify things. And is that what's happening here? That we have the same thing, I guess, with brown dwarfs. Are they stars or are they planets? And are we doing this here at the other end of the scale? Where is the demarcation line between what's a comet, how much ice and rock makes a comet compared to how much makes an asteroid? And when we look at some of the comets we've now visited, they don't look all that much different. And we're seeing some really icy asteroids out there as well.
I think you're right. There's definitely more of a spectrum when you're looking at these objects. And we try and put names on them. And something that I find quite interesting is when we talk about rocks coming through our atmosphere, there's actually a name for objects in our solar system that are smaller than 1 meter. It's called a meteoroid. And it doesn't matter whether it's cometary origin or asteroidal origin. We still call it just a generic meteoroid. And it's size-based. But who's to say that when it gets to 1.2 meters that it changes suddenly? So we do like to kind of categorize things, but there definitely is a spectrum. And I think an understanding of how the percentages of icy versus rocky in these bodies is what's going to help us understand and inform these models better in the future of how our solar system formed.
When these bodies come through the atmosphere and they burn up and the fireball network catches them, is it possible to get a spectra, or is that not possible with current technology?
Thank you for the lead-in. Getting a spectra of fireballs is something that people have been desperately trying to get into, and the hard thing so far has been that these spectral instruments are quite narrow field of view. So to be able to capture one in your narrow field of view is quite a unique or rare or lucky occurrence. So a lot of the data we have on meteor spectra are for meteor showers from cometary material, typically. When you know that there's a shower, you know there's going to be lots of material flying around, you can just point your spectral instrument up and you're more likely to get lucky during a meteor shower. But something that we're actually doing at the moment here in Australia is we're partnering with some colleagues from Slovakia, and we've put out a few all-sky spectral instruments in the middle of the nullarbor. So we have got a few hits already, which are pretty exciting, and we're starting to look into those now. But hopefully we'll get a few more events like that in the future, because obviously when we're trying to match the chemistries of these objects to their orbits, we can do that through the meteorites themselves. So if they survive the atmosphere, we can go and recover the meteorite, we can analyze their chemistries, and we can match that to different orbital areas of our solar system. But you can also do that, as you say, through spectra as well. And you don't have to have a meteorite that survives. But obviously it is a bit harder to do, but we're getting there.
What do you think is the Oort cloud? Is it just vagabonds from the solar system, or is it a mix of objects that were from the solar system's formation and things that just got caught up in the sun's gravitational field from interstellar space? Is it stuff that the sun's stolen from other stars early in its formation?
I think it's a mixture of both. There's definitely a lot of material from the early solar system that got thrown out and didn't quite make it to escaping. But we do have interactions with other stars although it sounds really long timescales, 200 million years, we do actually come close to other stars. And those are the times when material that's stuck in the Oort cloud can actually get thrown back into the inner solar system, like this object that we saw over Alberta that probably came back to the inner solar system after the last time we passed our nearest star about 70,000 years ago. So there's nothing there really saying that, well, we came close to another star, our Oort cloud got affected by it. We probably picked up some material along the way as well. Although it's now gravitationally bound, it's going to be really hard to prove whether they come from our solar system or not. But there are a few different ways that we would be able to tell that if we actually picked up a meteorite. If we managed to pick up a meteorite that was not formed from our solar system, there's some geochemical markers, especially in the isotopes of those elements, that we could actually use to figure out that they may predate our own solar system and that we might have stolen it a while ago in the past.
Well, we've seen that with some carbonaceous chondrites, haven't we? That they've got just these really great CAI mixtures.
Yeah, for sure. And we call them pre-solar grains. There's definitely some of those have pre-solar grains entrained in the meteorites themselves. But we still think that those were actually captured into those meteorites in the early solar system. And those meteorites were formed in our own solar system, but they just captured material from previously that was just hanging around out there. But actually to find a meteorite that its entire composition and formation predate our own solar system would be amazing.
That's Dr. Ellie Sampson from Curtin University. And this is SpaceTime. Still to come. The Artemis 1 mission declared a massive success following its splashdown in the North Pacific Ocean, and nuclear fusion achieved in the lab. All that and more still to come on SpaceTime.
Well, shopping for a car?
Yep, Carvana made financing a car as smooth as can be.
Oh, yeah?
I got pre-qualified instantly and had real terms personalized just for me.
Doesn't get much smoother than that.
Well, I got to browse thousands of car options on Carvana, all within my budget.
Doesn't get much smoother than that.
It does. I actually wanted a car that seemed out of my range, but I was able to add a cosigner and found my dream car.
It doesn't get much...
Oh, it gets smoother. It's getting delivered tomorrow.
Visit Carvana.com or download the app to get pre-qualified today.
NASA's Artemis 1 Orion spacecraft has successfully splashed down in the North Pacific Ocean, 160 kilometres west of Baja, California, ending its record-breaking 2.6 million kilometre journey beyond the moon and back. The splashdown of Orion occurred 50 years to the day of the Apollo 17 moon landing, the last time humans walked on the surface of another world. Orion's splashdown occurred some 482 kilometers south of the original target zone after NASA changed the target point following forecasts of choppy seas and high winds off the Southern Californian coast. The splashdown was the final milestone of a flight which began with a successful launch aboard the world's most powerful rocket, NASA's new Space Launch System, the SLS, back on November the 16th from Space Launch Complex 39B at the Kennedy Space Center in Florida. Over the following 25.5 days, NASA tested Orion in the harsh environment of deep space as part of preparations for what will be the first manned mission of Orion that'll be aboard the Artemis II flight in 2024. Mission managers say Orion successfully operated in the deep space environment, exceeding all expectations. During the mission, Orion performed 2 lunar flybys, coming to within 129 kilometers of the Moon's surface. At its most distant, Orion was over 435,000 kilometers from Earth, far beyond the Moon, and over 1,000 times further than the International Space Station. Other than a brief unexpected communications blackout during the outward-bound journey, the only problem encountered during the mission was some sudden power issues. A power unit aboard the Orion spacecraft suddenly turned off 4 devices responsible for downstream power associated with the vehicle's propulsion and heating systems just prior to successfully completing a crucial engine burn near the Moon. NASA says mission managers quickly applied a fix and successfully repowered the affected systems. They say there was no power interruption to any critical systems and there were no adverse effects to Orion's navigation or communications. At this stage, engineers still aren't sure whether the issues linked to earlier problems with the same systems, which are known as umbilical latching current limiters. Back on day 5 of the mission, one of 8 of these devices suddenly opened without command. Mission managers quickly commanded the device to close again, which it did without issue. Prior to entering Earth's atmosphere, the Orion crew capsule separated from its service module, which was the spacecraft's propulsive powerhouse provided by the European Space Agency. During its fiery re-entry back to Earth, Orion endured temperatures of some 2,760 degrees Celsius. And within about 20 minutes, Orion slowed from some 40,000 kilometers per hour down to just 30 kph for its parachute-assisted splashdown.
Orion is approaching the northwest coast of Australia, now just 1 minute away from crew module, service module separation. We'll be standing by for confirmation of that from the mechanical systems officer here at Mission Control. This will come at an altitude of 3,200 statute miles. We have confirmation of separation, Orion flying on its own. Again, the separation occurred right on time at 11 a.m. and 11 seconds Central Time, with Orion 3,200 statute miles away from Earth. The European service module has done its job. So with Orion flying on its own, we're about 18 and a half minutes away now from the point of entry interface, where Orion will be put through its paces. This is where the heat shield will begin to feel the effects of peak heating of 5,000 degrees Fahrenheit on the heat shield, and the beginning of 2 blackout periods where the plasma around the vehicle will build up such that it will block data and communications between mission control and the spacecraft itself. Orion continues to fly smoothly on, all of its systems in excellent shape, and the crew module raise burn that we thought was not going to be needed is being conducted, just basically a fine-tuning of the orientation and the angle, a 16-second firing of the thrusters, and a good burn reported, 8.12 feet per second in a change in velocity. So the raise burn was executed. That will further fine-tune Orion's path at the proper azimuth or orientation, where the heat shield is at its optimum angle, to begin the repulsion of the heat that will build up around the heat shield at the time that we begin entry interface. Entry interface is scheduled at 11:20 and 14 seconds a.m. Central Time at an altitude of 400,000 feet. At that point, Orion will be traveling 24,464 miles an hour with a range to splashdown of 3,659 statute miles. Flight controllers reporting a solid lock with the tracking and data relay satellite system, receiving data that's being processed through the TDRS network. Just a reminder that after we pass into the Earth's atmosphere at the speed at which we're going, and with the temperatures expected to build up very quickly for peak heating around the heat shield of Orion, we will begin the first of two blackout periods, the first of which is scheduled to begin at 11:20 and 16 seconds a.m. Central Time and will last about 4 minutes and 48 seconds. At that time, entry guidance, which has been stored on board, pre-programmed commanding for Orion to continue to point its way toward the splashdown zone, will take over. The first blackout period should end around 11:25 and 4 seconds Central Time. That will set the stage for the skip entry, basically the maneuver that will enable Orion to dip into the Earth's atmosphere and skip back out of the Earth's atmosphere and dip back into the Earth's atmosphere like a rock, a flat rock on a pond that will continue to dissipate energy and heat on the spacecraft, and is a maneuver that data will be gathered for to try to bring in multiple splashdown sites for crewed missions in the future. The second of the two blackout periods is scheduled to begin at 11:29 and 3 seconds a.m. Central Time, and that will last for about 2 minutes and 50 seconds till about 11:31 and change. That'll be the final blackout period, after which we should lock up solidly for the remaining 8 minutes or so until splashdown. This is Mission Control Houston, 12 minutes away from entry interface. Everything is going by the book so far here in Mission Control, very quiet on the loops. Entry Flight Director Judd Freeling and his team of flight controllers watching carefully over their data as they oversee the arrival of Orion for its splashdown site west of Baja, California. Time to splash down 31 minutes. During the period of the two blackouts, and even after we have emerged from the second of the two blackouts, Orion, through a series of pre-programmed commands stored on board, will conduct a series of role reversals. This is very much like space shuttles conducted during their entries back to Earth, where it will roll to the left and then back to the right, banking role reversals that will bleed off excess energy, excess inertia, and speed, and control the thermal characteristics of the vehicle as it heads towards its subsonic point, where it will go under Mach 1. It will go subsonic at about 11:34 and 55 seconds a.m. Central Time, some 5 minutes before splashdown. If everything goes as planned, Orion will reach an altitude of 40,000 feet at 11:35 a.m. Central Time, just about a minute before forward bay cover chute deploy begins. The series of 11 chutes, 3 that will pull the forward bay cover off of the top of the crew module. That'll be followed by the deployment of the drogue chutes, and then the 3 large main parachutes, 3 orange and white parachutes. That'll be the moment we'll be waiting for. 27.5 minutes until splashdown. We're just 8 minutes away from the point at which Orion will dip into the Earth's atmosphere and begin what basically is a hellish entry, where temperatures around the spacecraft will raise to about 5,000 degrees Fahrenheit. That's half as hot as the outer surface of the sun. Orion is actually traveling over the South Pacific at the moment, moving from south to north, currently traveling at 23,000 miles an hour. We're about 5 minutes away from entering the first of the two blackout periods, which will last about 4 minutes and 48 seconds. A journey that began with the power of the launch of the Space Launch System 25.5 days ago, about to reach its final minutes in the searing heat of re-entry, where temperatures around Orion will build up to 5,000 degrees Fahrenheit. Traveling just under 25,000 miles an hour with a range to splashdown of 3,659 statute miles. We're going to be losing all of the data here shortly once we enter into the Earth's atmosphere and begin the first of the two blackout periods. Entry interface has begun. Entry interface at 400,000 feet. Orion traveling just under 25,000 miles an hour. This is the moment of truth for Orion. When we emerge from this first blackout period, we'll be at an altitude of 274,000 feet, traveling just under 17,000 miles an hour with a range to splashdown of 2,000 statute miles. Standing by for a reacquisition of signal. And we have data from Orion. Orion out of the blackout period. Flight Dynamics reports that Orion is right on the money, coming right down the pike. We should be performing the skip entry maneuver momentarily. Good communications established with Orion. The second blackout period to begin about 2 minutes from now. Orion is at the apogee of the skip entry maneuver, beginning the second in a series of role reversals, again banking maneuvers to bleed off excess inertia and to dissipate heat around the spacecraft. The start of the second blackout period, about a minute and 13 seconds from now, will come at an altitude of 270,000 feet, with Orion traveling about 16,400 miles an hour, range to splashdown less than 1,000 miles. We should be in that second blackout period right now. Orion approaching a velocity of 20 times the speed of sound. If all goes as planned, we should be out of the blackout period with a solid lockup on the vehicle at 11:31 and 46 seconds a.m. Central Time. This is Mission Control Houston, the airborne WB-57, one of the airborne assets to track Orion's return to Earth as visual acquisition of the vehicle. We should be coming out of this second and final blackout about 30 seconds from now. And helos flying off the deck of the USS Portland now have a visual acquisition of Orion as well at an altitude of 174,000 feet, traveling 12,600 miles an hour, range to splashdown 288 statute miles. We have data back from the spacecraft. Flight Dynamics reports Orion straight and narrow on a true course toward its splashdown site. Forward bay covered jettisoning less than 3.5 minutes from now, 150,000 feet off the ocean. Orion now traveling at Mach 10. Orion's speed now down to Mach 6. Orion 100,000 feet now. The spacecraft about to go subsonic. Orion now at 50,000 feet. Forward bay covered jettisoning pyros are armed. 25,000 feet. Drogues have been deployed. 2 good drogue shoots reported by the recovery team out in the Pacific. The descent rate is right on the money. Orion's velocity now down to 282 miles an hour. Range to splashdown 1.5 miles. 10,000 feet now. And we're on mains. 5,000 feet. Reefing in progress. 3 good main chutes for Orion. We have 3 fully inflated main chutes. Time to splashdown 90 seconds. Perfect descent rate reported. And there it is. High over the Pacific, America's new ticket to ride to the moon and beyond now in view. Orion under its chutes descending towards splashdown. Orion in the perfect orientation for splashdown, just seconds away. 1,000 feet, good descent rate. 500 feet, splashdown. From Tranquility Base to Taurus Littrow to the tranquil waters of the Pacific, the latest chapter of NASA's journey to the moon comes to a close. Orion, back on Earth. At a mission elapsed time of 25 days, 10 hours, 54 minutes, 50 seconds. That's unofficial. Splashing down off the coast of Baja, California. The crew module uprighting system now being inflated for the bags currently being inflated. And we have a report that Orion is stable 1, upright, the way it should be. Splashdown occurring at 11:40 a.m. Central Time, 9:40 a.m. Pacific Time, west of Baja, California, after a textbook entry for the Orion spacecraft bringing its 25.5-day mission to an end. Orion's recovery beacon is on. This is Mission Control Houston. Once again, the Orion spacecraft, having completed a journey of 1.4 million miles, bobbing gently in the Pacific Ocean. It is in stable 1 configuration in good shape according to the recovery team, and we are now receiving word that all 5 of the crew module uprighting system bags are fully inflated. So that's exactly what we had hoped for. Orion safely bobbing up and down in the Pacific Ocean. We are estimating that it splashed down around 5 nautical miles away from the USS Portland. The recovery ship and Navy boats and divers will be approaching the vehicle before long. First of the Navy helicopters now approaching the vehicle. And here in Mission Control, some of Orion's systems no longer needed are being powered down. Many of them will stay powered up for the next 2 hours while we conduct a series of test objectives to characterize the thermal conditioning of the spacecraft. That will be important for future data for crewed missions to determine how long the crews can remain comfortable inside a vehicle returning from the moon. We also will be conducting tests of the beacon and SARSAT system for maintaining tracking of the spacecraft for recovery forces that will be approaching the spacecraft in the future. And coming up in the next hour and a half will be the reactivation of an ammonia boiler system that will provide cooling in the spacecraft as it will when crews return from their missions on board Orion.
During its test flight, Orion stayed in space longer than any spacecraft designed for astronauts had done without docking to the space station. And while in its distant lunar retrograde orbit, Orion surpassed the record for distance travelled by a spacecraft designed to carry humans previously set during Apollo 13. Following its splashdown, helicopter and inflatable boat recovery teams converged on the capsule and quickly secured Orion aboard the USS Portland, which then proceeded to San Diego. The recovery operation consisted of a large team, including specialist personnel and assets from the US Department of Defense, including Navy amphibious specialists, Space Force weather meteorologists, and Air Force technicians, as well as engineers and scientists from NASA's Kennedy Space Center, the Johnson Space Center in Houston, and from Lockheed Martin Space Operations. Once back in port, Orion was transferred back to Kennedy, where teams opened a hatch and unloaded several key payloads, including the mannequins used for radiation and G-force experiments during the flight. Next, the capsule and heat shield will undergo testing and analysis over the course of several months. Artemis 1 was the first integrated test of NASA's deep space exploration systems, designed to return humans to the Moon, this time to stay, and eventually onto Mars and beyond. And it's designed to be a reusable system, with some Artemis 1 components to be reused aboard the manned Artemis 2 flight. Artemis 2, which is slated for launch in 2024, will take humans on a trip around the Moon and back to Earth. And Artemis 3, which is currently slated for flight in 2025, will see humans back on the lunar surface, with the Orion spacecraft docking with a pre-positioned SpaceX Starship HLS, which will transport 2 of the Artemis 3 crew members down to the lunar surface for what will be a week-long stay near the South Pole. At this stage, NASA thereafter plans to launch at least 1 mission to the Moon every year. And so production continues on both launch vehicles and spacecraft for the missions. Right now, the SLS core stage for the Artemis 2 mission is scheduled to be completed and delivered to the Kennedy Space Center next year. And the engine section for Artemis 3 is already at the Kennedy Space Center, where it's being outfitted in preparation for integration with the rest of the rocket. NASA's also finalized a $3.2 billion contract with Boeing to continue manufacturing core and upper stages for future Space Launch System rockets for future Artemis missions. This will see some production facilities moved from Louisiana to the Kennedy Space Center in Florida. Back in 2019, NASA provided initial funding and authorization for the Artemis 3 core stage. Under the new contract, Boeing will have funding to complete construction of SLS core stages not just for Artemis 3, but also for the Artemis 4 mission, and they'll be commencing work on the core stages for Artemis 5 and 6. Boeing will also be providing the upper stages for the Artemis 5 and 6 missions. Now, currently, as part of NASA's contract with Boeing, they may order up to 10 core stages and 8 upper stages to support future Artemis missions through into the 2030s. But they won't all be the same. The SLS rocket is designed to evolve to more advanced configurations as needed to power future missions. Each SLS rocket configuration uses the same 65-meter-tall core stage, equipped with 4 Space Shuttle RS-25 main engines and 2 strap-on solid rocket boosters, also based on designs originally used on the Space Shuttle. In all, that produces more than 2 million pounds of thrust, more than any other rocket, including NASA's famous Saturn V Apollo moon rocket. For the first 3 Artemis missions, the SLS uses an interim cryogenic propulsion upper stage equipped with a single RL-10 engine. These are a stretched and human-rated version of the upper stages used aboard the United Launch Alliance Delta IV launch vehicle. But beginning with Artemis 4 comes the SLS Block 1B rocket configuration, and it'll feature a more powerful exploration upper stage, which uses larger fuel tanks and 4 RL-10 engines to send an Orion capsule and a large cargo capacity to the Moon. And of course, the SLS isn't alone in the mega rocket stakes, with SpaceX continuing development work of their own new mega rocket, the Starship, which Elon Musk has designed to become the first colonial interplanetary transport vehicle. We are indeed moving into exciting times. This is SpaceTime. Still to come, nuclear fusion achieved in the lab. And later in the science report, paleontologists in Brazil have identified a new species of titanosaurian sauropod dinosaur. All that and more still to come on SpaceTime.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
Scientists in the United States have achieved a major milestone in nuclear fusion research, producing a net gain of energy for the first time. The research team from the Lawrence Livermore National Laboratory's National Ignition Facility in California fired a bank of 192 high-powered lasers at a target fuel pellet, generating temperatures multiple times that at the center of the sun, and in the process triggering a nuclear fusion reaction within the pellet, releasing more energy than what it took to trigger the fusion event in the first place. The experiment surpassed the fusion threshold by delivering 2.05 megajoules of energy to the target, resulting in an output of 3.15 megajoules of fusion energy. Known as a net energy gain, it's a major breakthrough in the decades-long quest to harness the same process that powers the sun. United States Energy Secretary Jennifer Granholm describes the historic achievement of fusion ignition as one of the most important scientific feats of the 21st century. Scientists see nuclear fusion as a limitless, clean method of energy production using seawater, one that will ultimately help end global warming and climate change. Current nuclear power stations use nuclear fission, in which uranium atoms are split apart, releasing tremendous amounts of energy to heat water, make steam, and spin turbines to generate electricity, and unfortunately also producing high levels of radioactive wastes. More than 10% of the world's electricity comes from nuclear power plants. And that's only going to increase as the world moves away from coal-fired power as a baseload energy source. Nuclear fusion produces energy by forcing two hydrogen atoms together, forming a helium atom and releasing high-energy neutrons. Now, in the sun, this process happens naturally because core temperatures exceed 15 million degrees Celsius and pressures reach some 3.84 million pounds per square inch. That's some 26.5 petapascals. But duplicating these extreme conditions on Earth has proven to be far more difficult, and the entire process has become the holy grail of nuclear fusion since the 1950s. The laser fusion process employs ultra-short picosecond bursts of very high-energy lasers, producing the extreme temperatures and pressures needed to trigger a fusion reaction. These laser pulses can heat and compress hydrogen isotopes to just a fraction of their size, forcing them to fuse into helium and releasing high-energy neutrons. The Lawrence Livermore National Laboratory's National Ignition Facility in California achieves deuterium-tritium nuclear ignition using a laser producing over 2 million joules of energy in a sudden pulse lasting just a nanosecond. That's 1,000 millionth of a second. Normal hydrogen is also known as protium, and it consists of a single proton in its nucleus orbited by just one electron. Deuterium differs in that its nucleus also contains a neutron, and tritium has a proton and 2 neutrons in its nucleus. But laser fusion ignition is only one of 2 paths physicists are following in their quest to achieve nuclear fusion. The other involves magnetic confinement fusion, in which a superheated plasma is confined in a donut-shaped ring called a tokamak using powerful magnets. The plasma is made up of heavy and superheavy isotopes of hydrogen, deuterium and tritium. These isotopes are heated to 100 million degrees Celsius by powerful electric currents within the tokamak. At these extreme temperatures, the electrons are ripped from their atoms, forming a charged plasma of hydrogen ions. Cryogenically cooled magnets confine the plasma to an extremely small area within the ring, maximizing the chances that the superheated ions will fuse together, giving off energy. And once again, the heat generated can be used to turn water into steam, which spins turbines producing electricity. Right now, there are more than 200 experimental tokamaks around the world. But to date, they've all consumed more energy than they produce. A massive international tokamak project, ITER, the International Thermonuclear Experimental Reactor, is now under construction in southern France with the aim of starting operations in 2027. Meanwhile, physicists in Germany are using a variant of the tokamak known as a stellarator. It uses a twisting ring design with changes in geometry and differing magnetic fields in order to control the plasma for longer periods compared to the short bursts which tokamaks achieve. And while the laser fusion process now appears to have passed a major milestone, there's still a long way for that to go before it reaches commercial viability. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. A new study has found that a plant-based diet could reduce the risk of colorectal cancer in men. The findings, reported in the British Medical Journal, are based on a study looking at the diets of some 80,000 men and 90,000 women. It compared rates of colorectal cancer over nearly 20 years. The authors say that among men, a diet with the highest amounts of whole grains, vegetables and legumes was associated with a 22% lower risk of colorectal cancer compared to a diet with the lowest amount of these foods. Interestingly, the researchers say this same difference wasn't found in women, which they believe could be because women already tend to have a naturally lower risk of colorectal cancer than men. Paleontologists in Brazil have identified a new species of titanosaurian dinosaur. The newly identified species, reported in the journal PeerJ, is based on 10 anterior and middle caudal vertebrae. The dinosaur has been named Caerita alicudata and was found in late Cretaceous strata dating back between 70 and 66 million years. Like other sauropod dinosaurs, titanosaurs were herbivores, with elephant-like bodies and legs, with a long neck and small head at one end and a long tail at the other. But they differed from other sauropods in that they had stockier bodies and a wider stance. A new study warns that if you suffer from psychosocial stress, which happens when you believe your social status is being threatened, you may have an increased risk of stroke. The findings, reported in the Journal of the American Medical Association, looked at the health records of 26,812 people from 32 countries. They found that 13,462 of them had suffered a stroke. Periods of stress and permanent stress were reported by 2,745 of the stroke patients, that's some 20.5%, but by just 1,933 people, or 14.4% of the non-stroke group. The researchers say increased stress at home and work, as well as recent stressful life events, are all linked to an increased risk of stroke. Of the countries investigated, psychosocial stress levels were found to be lowest in China and highest in Southeast Asia. The study found that people who felt most in control of their lives, both at home and at work, were the least likely to have a stroke. And feeling in control helped offset the risk of stroke from psychosocial stress. Well, the glittering highlight of the Australian Skeptical calendar, the annual Skepticon conference, is over for another year, this time held in the national capital, Canberra. And of course, the highlight of the event is the coveted Bent Spoon Award, which is presented annually to the perpetrator of the most preposterous piece of paranormal or pseudoscientific piffle. The award is rumoured to have been fashioned out of a piece of gopher wood salvaged from Noah's Ark. And upon its sturdy base is affixed a spoon rumoured to have been used in the Last Supper. That spoon was allegedly bent by Uri Geller, using old magic energies unknown to science. Past winners of this elegant and highly prized trophy, displaying a total lack of scientific understanding or credibility, have included the Australian Broadcasting Corporation, the ABC, for demonstrating new lows in journalistic standards with their motto, "Never let the facts get in the way of a good story." The University of Wollongong, for proving once and for all that you don't need to be smart, or right, or even scientifically accurate to get a doctorate. Adelaide psychic Annie Dankbar for her discovery of the Colossus of Rhodes, which created something of a media frenzy until it was shown to be nothing more than modern-day builder's rubble. The ABC won the award for their television show Second Opinion, which promoted so much unscientific quackery, they really should have sought a few more opinions. Southern Cross University won the award for actually offering a degree course on naturopathy. And of course, who can forget Paleo Pete Evans for his promotion of the Biocharger, a miraculous device that, according to its manufacturers, has been proven to restore strength, stamina, coordination, and mental clarity. Evans, of course, is a dual winner, having previously won the spoon in 2015 for his paleo diet advocacy, which included promoting bone broth as a formula replacement for babies, as well as his campaigns against fluoridation and vaccines. The CSIRO's chief, Larry Marshall, won the award for supporting water divining, and the ABC won the award for spending taxpayer money on psychic investigators. And we haven't forgotten the sporting world. Racing driver Peter Brock won the award for his highly touted energy polarizer, which generated more heat in the motoring media than it did energy in his car. The SBS got the bent spoon for their television program Medicine or Myth. It promoted alternative medicine treatments as if they had some scientific credibility, which they don't, other than the occasional placebo effect. The Melbourne Metropolitan Board of Works won the award for hiring a US psychic archaeologist, yes they do exist apparently, and who was apparently able to detect a non-existent electromagnetic photo field. Oh, and once again the taxpayer ABC won the award, this time for their television show The New Inventors, which seriously considered the pseudoscientific benefits of what they called anti-bio water conditioning systems. Tim Mendham from Australian Skeptics says this year's winner came as somewhat of a surprise.
Ben Spoon is, of course, awarded for the most preposterous piece of paranormal piffle. Every year we give it out, ever since 1982, actually, except for 1 year in which obviously nothing happened. But we gave it out at our national convention, which was in Canberra. It was a bit of a slow year, actually, because we didn't have any of the high-profile people we often have who are around. They've obviously gone into hibernation. People like Paleo Pete Evans, who's the only person who's won it twice, and then few other people in the high-profile names in politics and media or wherever. So this year we had some people who were sort of still worthy, by all means, but perhaps not quite as well known. For instance, the fellow who was a dowser, water diviner, who could make restructured water or hexagonal water by spinning it through a couple of soft drink bottles and selling it for large amounts of money. He was a runner-up, though, actually. So the winner was actually a person named Maria Carmela Powell. Now, she is a doctor. She's not a medical doctor. Nonetheless, she was handing out certificates for COVID vaccine exemptions to people for a price, and not out of the goodness of her heart, for a price. And she apparently sent out about 1,200 of these certificates to people. Totally useless. They couldn't use them, but anyway. And pocketed $120,000. She was charged for it by the police and taken to court in Queensland, where she lives. She was charged over fraudulent pandemic paperwork. She was fined. She could have been fined $60,000 and a 3-year imprisonment, but instead she was only fined $25,000, no conviction recorded. Anyway, the award went to her. It could have gone to the court, I presume, and it was roundly supported by a series of boos from the audience who regarded her as a very worthy person to win it. So that's Maria Carmela Powell, who is not only a non-medical doctor, she's also an actress and a model and a spiritual insights coach.
Of course she is.
Of course she is.
Okay.
So that was our Ben Spoon Award. Yeah.
That's Tim Mendham from Australian Skeptics. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.